My name is Yael. I am working as lead additive manufacturing consultant for AOS Additive Mines and focusing on process chamber topics like powder, process parameter optimization, process qualification, and process monitoring. In this video, I will explain the formation mechanisms of different overheating problems and potential use of smart fusion technology to solve these issues. The laser powder bed fusion process is indeed transformation of energy in laser beam into metal powder and melting this powder, leading to the desired part geometry. And the smallest repeating unit of this process is called H vector. In a usual additive manufacturing job production, in total, hundreds of kilometers of H vectors are applied to get a part built. Since the geometry of each part is unique, the heating and cooling cycles of each position on a part may not be 100% same. These differences may lead to irregularities such as overheating problems. At the first look, it seems to be a chaotic like glowing melt pool, flying particles, moving recorder arm, and so for an observer. At AOS, we see it differently. The production in metal additive manufacturing starts with machine setup, namely cleaning the machine, filling up the powder, and precisely placing the build platform. Afterwards, we flood our machine with protective gas, which will be assuring the stability of laser material interaction. The process starts only after establishing proper conditions. The scene now belongs to the scanner-controlled lasers, protective gas flow, powder, solidified material, and also monitoring sensors such as oxygen sensor or air state exposure OT camera. We are strongly committed to understand, monitor, and optimize the complex interplay between process parameters and part quality by keeping an eye on productivity and sustainability. Let's have an overview of different mechanisms that are causing overheating problems during additive manufacturing. The very first reason can be short vectors that can cause overheating. The second reason may come from the part design that are mainly the overhang areas building on top of the powder bed. Another reason can be the increasing Z height. Last but not least, the layer time changes may also cause overheating problems. The very first reason of formation of overheating problems are short vectors. At AOS, we qualify our processes with the ideal and optimum length of vectors. But due to the geometry of the part and rotating of vectors at each layer, some vectors could be shorter than the others. And this will affect the speed of heating and cooling cycle, which may end up with overheating problems. This effect mainly causes increased Z height and roughness on these areas and may cause recording crashes and job interruption. To solve this problem, we have different features at our AOS Mines software, which is called minimum vector time. So with this feature, the overheating vector length can be precisely defined and additional waiting time can be introduced to let these areas cool down. To find the exact length of the vectors that are causing overheating, you can use air state exposure OT. Another option is power reduction factor, that decreasing of laser power at these areas based on a formula on the length of the vectors. Since short vector induced overheating is a very local and non-repeating phenomenon, smart fusion is not a possible or is not a potential solution to this problem. The second forming mechanism is overhang. Overhang means a location on a part that is being exposed, that is being melted on the powder bed. And the heat conductivity of powder bed is less than solid material. This may cause accumulation of heat in this area during cooling and leading to overheating. This kind of overheating is very dangerous because it increases the thermal residual stresses and distortion risk of a part that may cause job crashes. Smart vision technology uses OT pictures to detect such areas and regulate the process in a very precise manner, namely with 100 micron resolution, and decreases the overheating, decreases the energy on these areas to avoid residual stresses and overheating. The third mechanism that may cause overheating is the increasing Z height. As a part is built up, the distance to the build plate, which may act as a heat sink, will increase. And the part itself may have different cross sections, that means different heat carrying capacity. Maraging steels and nickel alloys are more sensitive against this phenomena, but all materials, all processes can be affected. As the Z high increases, the temperature of a part may increase, which will cause increased oxygen pickup, coloration, or deformation of a part. Again, smart vision technology uses aerostat exposure pictures to detect this kind of gradual increase in the temperature of a part and precisely regulating the process, decreasing the laser power on the affected areas based on the degree of overheating, and will regulate and homogenize the process conditions throughout the Z height of each part. Last but not least, change of cross-section, thus the layer time, may also cause overheating. Since we are building complex parts in additive manufacturing, we do not always build the same cross-section. Mainly decrease in the cross-section and the layer time will decrease the time for a part to cool down and cause overheating. This overheating can again be detected by aerostat exposure OT pictures, and smart vision will again regulate the affected areas and bring us homogeneous process conditions independent of the layer time and cross-section. It was all about different overheating mechanisms and how we can utilize smart vision technology to overcome these issues. Thank you for watching.